Hello friends, welcome to this session on data visualization with Matplotlib and Seaborn. In today's digital age, data is everywhere, but simply having data isn't enough. We need to be able to understand it, analyze it, and most importantly, visualize it. So that is where Matplotlib and Seaborn come in. So, hi everyone. I'm Himanshu Bhardwaj, and in this lecture, we are going to dive into the exciting world of data visualization using two powerful Python libraries, Matplotlib and Seaborn. Whether you are a data scientist, a researcher, or just someone curious about data, mastering these tools can take your analysis to the next level. So what exactly are Matplotlib and Seaborn? So Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. It is incredibly flexible and allows you to create a wide range of plots from simple line graphs to complex 3D plots. Seaborn, on the other hand, is built on top of Matplotlib and provides a higher level interface for creating attractive and informative statistical graphics. It simplifies the process of creating complex visualizations and comes with built-in themes and color palettes to make your plots visually appealing. In this lecture, we will start with the basic and gradually work our way up to more advanced techniques. We will cover everything from simple plotting to a more complex data visualizations. By the end of this lecture, you will have the skills and confidence to create stunning visualizations for your projects, particularly for the marketing analytics projects. But before we dive into the fun stuff, let us make sure we have Matplotlib and Seaborn installed. If you haven't already installed it on your system, then you can visit, you can use pip to install the package manager. You can Google it for installing Matplotlib and Seaborn, and you will get the how to install Matplotlib and Seaborn using pip. So pip command you can use on your command line and install it. Now, once you have Matplotlib and Seaborn installed, you are ready to start visualization data like a pro. In the next video, in the next we will explore. We will do exploratory data analysis with Matplotlib and Seaborn. So let us start the exploratory data analysis with Seaborn and Matplotlib. So first of all, let us load the data. So this is the data set. This statement loads the data set from CSV file, product analytics data. So this file is in the same folder where this Jupyter notebook resides. So make sure that the CSV file is in the same folder. If it is not, then you can provide the path also. So instead of giving just this file name and with CSV extension, you can give the path also. For example, if it is located somewhere in your D drive, so you can give the path also like this or the entire path. So the data will be loaded. So this is a data set in which you can see the information of customer ID, state, customer lifetime value, and various other demographic and income informations are there, along with certain other information. So these information are given. So you can also know the structure of this data table by using this statement df.info. So this will give you the various list of columns in the data set. So here you can see there are 23 columns in the data, 24 columns in the data sets. So starting from 0 to 23. So there are various columns. Some are numerical variables. You can see this, these are float values are numerical variables, whereas the other are categorical variables. And also you will find ordinal variable also. So ordinal or numerical or categorical. So so these three kinds of variables are there in the data frame. So you can now explore how to what insight this data set provides you. So this is a prerequisite for any marketing analytics task. So if you have a data set, then the first thing you do the data pre-processing means you remove noise, edit data set, or uh, you remove the wrong values and the outliers from the data set. Then the next step is to do exploratory data analysis. So we will do this part, means the exploratory data analysis part here. So let us start with the descriptive statistics. So df.describe function will give you the descriptive statistics about the data set. So this single statement will give you the descriptive statistics, that is the mean, the standard deviation, the minimum, the quartile values means 25% to 75% quartile values, and the maximum and the total number of counts. So how many data sets are there? So you can see there are 9134 rows in the data set. So this is this gives you a basic descriptive statistics about the data set. Make sure that these statistics will provide only the numerical data set, not the categorical data set. Of course, there's no meaning of mean of a categorical data set. So it is used to define the category of the data. So this will give this will list down all the numerical columns, and you will find the descriptive statistics of the data set. Now moving to the next part. So let us uh, let us make another data frame with all the numerical column numeric data set. So select so these are the numerical data set, means either integer or float type. So you select this by this statement and make another data set or data frame. So I have done this because start with only numerical data set, then we'll create some categorical plot also. So numerical plots are, means start with the simpler one and then we will move to the more complex and complicated one. So here starting with the first is the correlation plot. So for doing any regression analysis or for knowing how one data varies with other, if we want to know, then we have to know the strength of correlation between the two data set data. So for example, how one data varies with respect to the other. If other varies, what is the impact of some other data set? So you, if you want to know, then you need to establish the correlation between the two data set. So either the data set will be positively correlated or negatively correlated, or a third situation that there is no correlation, means both are independently varying. There is no relationship between the uh, data set. So in that case, you will find correlation is almost zero or very low value. Whereas for negatively correlated data set, you will get a negative correlation value. For example, if one increases, other decreases. So you will get a negative correlation value. Similarly, if one increases and other also increases, so you will get a positive correlation value. So this correlation values you can get in a matrix form. So here is the correlation matrix that you can calculate with one statement. So this statement np dot coef. So cof will give you the correlation matrix. So you can print here and view the correlation matrix. So this will give you the all correlations of the numeric columns. So of course only numeric column will be having a correlation. So this will give you the correlation between all the numeric columns of the data set. And that is the reason why I discarded other non-numeric values. So you can create a heat map, because heat map give you a better way to analyze how data sets are correlated with one another. So here you can see how these numeric columns are correlated to one another. So if they are here, the scale is also given. So if they are positively correlated, so you will move towards the red side, and if the data set is negatively correlated, then you will move towards the purple side. So this, for example, income and total claim amount is negatively correlated, but there is a high correlation, but they are negatively correlated. For example, if income increases, the total claim amount decreases. Similarly, you can see monthly premium auto. This column has a positive correlation with the total claim amount. So it is somewhere between 0.6 to 0.8. So they have a positive correlation. So if monthly premium auto increases, so is total claim amount. So this heat map gives you a good insight about the correlations of numeric data in your data frame or in your database or data table. So you can visualize it, and you can see which one uh, uh, is more, which variable has more um, correlation with other variable. So in this, so if you are going to do regression analysis, so this will be the input, because on the basis of this you can select variables that uh, will be will be used as a predictor for regression analysis. Another use of this heat map is to for data reduction. For example, if you are doing principal component analysis, so you use this correlation matrix for reducing the dimension of the data set. So more correlated data, if data set are highly correlated, so they are reduced to 1 in principal component analysis. Similarly, in factor analysis, you use this correlation matrix. So to remove unnecessary data set and to reduce the dimension of your data set. So these are the main uses of uh, heat map or the correlation matrix. So particularly in regression analysis, you commonly do principal component analysis to have a better, because if you have highly correlated data in your data set as a predictor, then uh, its importance, or you will see that its predictor means few data set you will see that are unnecessary or have the uh, higher p value. So you have to remove those data set for better regression analysis. I will explain how this is done in the regression lecture. So let us move further. Now, Let us create a matrix plot. So suppose we have this numerical variables and we want scatter plot, and we want all the scatter plot by selecting any two from these numeric variables. So we can do this with one command by using sns.pair plot. So you will get the matrix of the entire scatter plot that can be formed. So here you can plot it with just one command. So this is the pair plots, means it select a pair and plot and do a scatter plot. So for example, income and customer lifetime value has a scatter plot and displayed here. Similarly, you can choose any two numeric variables and do the scatter plot, and you can use the categorical variable to as a color, means you can color code the using the categorical variable so that you can see the distribution of data. So this is one way. Another very important plot is the frequency distribution plot that you require in every analysis. Means if you do any data analysis, the first thing you do is to plot the frequency plot so that you can view the distribution of data, how data are distributed. So you can do this by using sns.histplot. And also you would be aware of kernel density estimate. So there are various probability distribution. Some are, the parametric uh, distribution, means if you have a data set, then you can say that this distribution belongs to a particular category, for example uniform distribution, or uh, say Gaussian distribution, or the binomial distribution or Poisson distribution. So these are kind of distribution are parametric, means they you can use parameters to define the distribution. For example, in the case of Gaussian distribution, you use mean and standard deviation to define the distribution. So these are parametric distribution. For example, in case of binomial distribution, you need to have the probability of success or unsuccess, or probability of occurrence and non-occurrence, and you can define the entire distribution. Or in case of these are the example of parametric distribution. There are some non-parametric distribution, and one of this is to know the kernel density estimate. Means sometimes we do not know what kind of distribution data has, so we just use kernel density estimate uh, to model the distribution of the data. So here you can set the kernel density estimate as false. So kernel density estimate will not be displayed in your histogram. And if you set it true, then the the histogram, the plotting will contain both the frequency plot as well as the kernel density estimate plot. So here I have set it true. So you can see the frequency distribution plot along with the kernel density estimate. So this is the facility that Seaborn provides you. And now I have flattened the axis, so you can plot at once, means all the plotting you can do with all the plotting you can do with only one command. So this is the way you can do all, you can do the frequency, you can plot the frequency plot for all the variable at once. However, in the case of if you have a very large number of variables, then don't use loop, otherwise it will slow down your speed, means you have to wait a lot. So it depends, if either you can plot it one by one, or you can do it once by running this loop. So this is the number of data columns. So if number of data columns is very large, then in that case the plotting will be very slow. So just keep in mind that you have a commendable, you have means lesser number of columns, then you can apply loop. Otherwise, I recommend you to plot with uh, means manually one by one. And the kind of plotting is, so this we have already discussed. Now let us do some more complex plotting using incorporating categorical variables also. Earlier we were using only the uh, numerical variables. Now let us incorporate the information of categorical variables. So here are few list, not all, uh, 8 numbers of categorical variable I have taken into consideration, and then I have created a plot. So this is a count plot, means this will give you the numbers, how many numbers of each of these categories are present in the data set. For example, under the state category, how many numbers are available? So there are 5 states: Washington, Arizona, Nevada, California, and Oregon. So how many data sets are there under each of these categories? So you can plot it with using the count plot. Similarly, whether on the basis of response count, you can know the number, how many number of data sets are there. So these are very important while doing machine learning, because in machine learning you need to have a balanced data set. So uh, if you are doing this classification task, for example, so generally classification task is done on categorical, means you use a categorical label for doing the classification. So in that case you require this kind of plotting, because you are interested to know how many data sets and are present under each category. So if there is an imbalance, then you have to create some synthetic data set to balance the data set. Otherwise your model will be highly uh, means variance of your model will be very high. So your model will be highly fitted, means overfitted with the data set. So in that case, the model will not be accurate. So these kind of plotting you use there. So this is a very important plot. So this you can use to know the numbers under each category, how many data rows are there under this category. So this kind of plotting you can do. So let us move to other plot. So these are the count plot that are very important plot. And this count plot is very important. And there is let us consider a continuous variable, and you if you want to know the average number of this on an average under which categories are there, means if you want to know the average numbers, so here you can use directly using sns.bar plot. So you can place the category at x axis. So here for example gender is a category, so male female, you place it on x axis. And the continuous variable, you can select any variable of your interest, and here I have taken number of policies. You can select any continuous variable of your interest if you want to know the information of that particular variable. So you can select, and you will get the average number of policy. For example, this plot indicates that the female category has an average number of less than three policies. So since it is a number, so this will be a whole number, but here just for the sake of plotting, I have shown this. So you can apply an integer or you can convert it to integer to know the. So similarly for male, you can plot it. Similarly, you can select any other item from the data set. So you can create this kind of plot. Let us take another numerical variables instead of number of data. So these are the continuous variables. So suppose if you want to know the okay, let us move to other kind of plot. So on an average, you got this that value. Now, uh, if you want to use some aggregate function like sum or mean or other aggregate function, you can use it. Here we are not using any aggregate function, so these are simply plotting the average value. But suppose if you want to apply some aggregate function, means under which, for example, if you want to know the sum under each category, then how you can do this? You can use it. You can use an aggregate function. For example, uh, here is the aggregate function of sum. Means here the estimator is the aggregate function. So here you can use estimator. As here I am using sum, so this will give you the sum under each category. For example, the under the category corporate auto, you will get the total sum of policies now. Earlier you were getting the average number of policy. Here you will get the sum of the number of policies. So if you want, so you can use any other function of your choice. So you can create plot like this under various categories. So offer 1, offer 3, offer 2, offer 4, you will get the sum in this case because I have used sum as an estimators. Now moving to other part. So this staked bar plot, this is also a very important plot and gives you a lot of insight about your data. So here you can, instead of earlier we were using only one categorical variable, now we can use two categorical variable. One you can place it at x-axis, other you can use it as a state bar. So here you need to create a pivot table first. So this statement creates the pivot table, and as you use in create the pivot table on Excel, so you have to use some aggregate function there. If you remember and if you know how to create pivot table on Excel sheet, then you would be knowing that you have to apply some aggregate function like mean or some value. So here also you have to supply the information of the aggregate function. So here I am giving the sum. So this will create the sum. So once the pivot table is created, now you can create the bar plot. So here pivot table dot plot, and you have to give the information what kind of plot you want. So you want a bar plot, and whether staked is true or not, then you set it true because you want to display the staked bar. So you can use it. So X label, which category you want to place. So if you, here two categories are there. So at 0 you have gender and at 1 you have uh, education. So this is a list. So list 0 means you are placing gender at x-axis, whereas you are using state means education for state bar. So this is the sample of stack bar. So this is one plot I have created. You can create in bulk, means you can create using loop. So here I have used loop to create various number of stack bar at once by choosing different continuous variables. So here I have used number of continuous variable, and you can create uh, more than one stack bar by using loop. So you can create, otherwise you can do manually also, one by one you can do. It will consume your time. So if you want to save time, then you can run this loop. And if you, because for every plotting you need to write code, so better writing code for every plotting, you create a loop. So it depends upon you. If you have a lot of time, you can do it manually also. So this is the remaining part. Now coming to the another very important plot, that is box plot. So if you want to know the quartile of your dataset, you need to do box. You need to present a box plot of your data. So this box plot gives you the quartile information of your dataset. So this, the lowest line, horizontal line, is the minimum. The this upper one horizontal line is the maximum, and this is the 25th quartile. The middle one is the 50th quartile, and this one is the 75th quartile of your data set. So this box plot will give you the information of quartile, and these are the, I think, the outlier. These are the outliers. So outliers means what? More than 3 standard deviation or more than 2 standard deviation you discard, you consider as outlier. So uh, these are the outlier. So similarly for other variable, you have this. For income, you have this box plot. So I have created once by using loop. So you can use SNS dot box plot to create such kind of plot. So I have used two categorical variables, and all I have taken all the continuous variable and create a loop to plot all the continuous variables at in one block, so that I should not in order to save my labor, I did that. You can do it manually also. So these are the box plot information. uh, and the modified form of this box plot is the violin plot. So you can create violin plot also on using Seaborn. So violin plot also not only gives you the quartile information, but also gives you the distribution also. So this shape, it looks like violin because it's a mirror image of the distribution of your data. So the left one is the distribution and right one is the mirror image of that. So it looks like a violin, but it gives you a lot of information. Like this dotted line are the quartile information. So the lowest dotted line is the 25th quartile, the middle one is the 50th quartile, and the upper one is the 75th quartile. And this is the distribution of your data. Similarly, for income, you get this kind of distribution, and also along with the quartile of your data. So you can visualize the quartile information of your data set. So this is also a very important plot and gives you a lot of information, statistical distribution information about your data set. So I have created this plot using the SNS dot violin plot. So this statement is important, SNS dot violin plot, and what you are using quartile information. So quart you will enter as in what data set you are using, df data set, as this is the data frame I am going to plot. Then this is the continuous variable, means this is the columns containing the continuous variable. So I'm plotting the continuous variable on y-axis and the categorical variable on x-axis. So you can create this very easily. So these are the violin plot. Now coming to the very commonly used plot for various analysis, the scatter plot. We have already done a kind of scatter plot, that is pair plot, earlier. I have shown you how to do pair plot at once, means it will select two pairs and create a plot. So in that way you can create all the pair plots. But here uh, you can do it individually also, means you can select two variables and create the plot. So this is the similar kind of plot. You can use categorical variable to give the color code, so that you can, if you also want to incorporate the categorical information, and then you can incorporate that also. So here the hue statement, here this hue statement, you can supply the categorical variable. So this will give you the color code. So x is the your first variable, y is the second variable, and if you want to give the color code, this hue, you have to assign some value, some categorical value to this hue. So if you assign this value, you will be having a different colors for different categories in the dataset. So these are important plots. So rest is the title and legend. So you go through it. I have uploaded the file. You download the file and go through all the codes. These are very simple and straightforward code. I recommend you two books. One is uh, the manual of Seaborn. So you go through the Seaborn manual, and you can also visit the website of Matplotlib. So there are various plotting are there. You can also download the Jupyter notebook from there also for variable plots, for various plot. And the book means what kind of plotting and how to create plot. For that, I recommend you to I recommend you to a book, a very interesting book. No, very interesting book. Its name is Storytelling with Data. So this is authored by Cole Nussbaumer Netflix. So Cole Nussbaumer Netflix authored a book, Storytelling with Data. So you will be having the a fair means how to create informative plots. Means every plot is not informative, some are garbage also. Means if you unnecessarily create plot and it doesn't give any information, is just the waste of time and labor. So better what kind of plot should be produced, this is given in the book. And various failure, means a great failure of uh, plotting is also quoted, means you know what not to do while creating the data visualization chart. So this is a very good book. I think you must read before doing this. So this is the scatter plot. Now coming to the pie plot. So pie plot gives you the distribution of the data set. So earlier you were creating the bar plot or the state bar plot, that not only gave you the sum of the value but also the state information means categorical information. Similar kind of information you can get it from the pie plot. So you will get the distribution of data under various category. You can plot it the percentage value or the actual value also. So here I have plotted the percentage value. So this is the statement that you will use to produce pie plot. So uh, here you need only Matplotlib, not the Seaborn. So you can use this pie statement. You can select any axis and then do the pie statement to pie function. This pie function will plot you the pie will plot the pie plot. So before that, you need to group this data set. So either you uh, use value counts or any aggregating function to group the data set. So here you are using the count, then you can use sum also. So here you can use sum also. So you can plot the sum. Here the plot was to know the count under various categories. So I was using the value counts aggregate function to know the counts under various category. For example, under various category of employment status, you just simply apply this aggregating function and you can get the counts under various category as we did in the case of bar plot. So here you can also do the same thing. And in case of continuous variable, suppose you are using, then you have to aggregate it with some function like sum or mean or any other aggregating function. You can use it and create the plot. So here you will get the percentage value. You can also annotate the actual value also, but here I have displayed the percentage value. Now coming to the next part is the very important part is the regression plot. So as you do on Excel, you simply just select two column and then create a correlation plot or correlation. Also you display the correlation equation or the regression equation along with the plot. Also you display the R square value also. So here you can produce the same thing with Seaborn. So Seaborn reg plot, this plot, this function reg plot will plot the regression plot for you. So scatter plot, you do not know the trend of the fitting line, but here you can also see the fitted line also, the fitted regression line also along with this equation. So this is the regression equation. So R square value gives you the strength of relationship. So you can also visualize that this information also. So here I have used loop to display more than one chart. So you can display one single chart only. You just apply the column on x-axis that you want to place and the column that you want to place at y-axis. You supply the data set and you just, since I'm using multiple charts, so for every chart there is an axis ID. So this information you need not to give in case of only producing only one single chart. So you can annotate and you can do this. So this file you can download and do your own experiment with by changing certain thing. So let us conclude this session. I think I have given a comprehensive list of chart that you can produce using Seaborn and Matplotlib. So with the help of these two packages which are free and open source, so you can create very informative charts and plots that are required for various kind of model building analysis, like regression models if you want to build a classification model, or if you want to produce if you want to do some optimization task or some information if you want to extract, then these charts are charts plays a very important role while developing a data driven insight for your business problem. So whether you are a marketing manager or marketing analyst, or uh, any, if you are uh, if you have function of any business, then you use these charts, whether finance or marketing or operations. So everywhere you require plotting and charting. So this, I hope this session is valuable for your work or for your career. So thank you very much for joining this session. In the next session, we will be discussing some more interesting topic on Python. So let us end this session. Thank you very much once again.